we go. So these are notes 10.5. So they're in between notes 10 and notes 11. That's because we need to practice before we do chain rule. So on notes 10.5, we're just practicing taking derivatives. You okay, miss?
Yeah, oh, yeah, I'm good.
Okay. Yeah, if you need to step out, I don't want. All right. Oh, yeah. All right. So here we go. Yeah, don't hit her. Oh, okay. So here we go, guys. The derivative. Question number 1. I'm just using the power rule. Y prime equals, you can also write dy dx, negative 8 x to the negative what? 3 minus 8. And that's it. If you want to turn exponents into a positive exponent, which we'll talk about today after school, negative 8 over x cubed minus 8. Are we okay? Okay. So some of you have a habit, I saw it on your circuit, that you write your derivative immediately after this, and you'll write it like right here next to it, or you'll do it right here. Don't do that. That is not correct. That is called a linkage error. If you do that, don't do that. Some of you are doing that. That's a linkage error. That is not correct. That's still, look, that says y equals, so you're saying this is y. That's what that. So if you're gonna say derivative, make a new line. Put a prime on it, or dy dx, however you want to express your derivative, and then write the derivative. Cool or not cool? All right, here we go. Question number 2. It might help you, instead of writing x cubed over 3, don't do quotient rule for that, guys. That 3 is a constant. Maybe it helps to do it like this, 1/3 x cubed minus x. That you can write equals because it's still y. Y prime equals, what's the derivative of 1/3 x cubed? 1x squared. Perfect. Because 1/3 times 3 is 1, and then you subtract 1 from that power. Minus, what's the derivative of x? 1. There it is. Leave it alone. Yes, that's a difference of squares, but you don't have to simplify. You don't have to show the factors. That's it. Cool or not cool? Okay. Question 3. You could, if you wanted to, use the quotient rule. But usually, when you have a constant, if you have a constant somewhere, you don't want to use the quotient rule. Just set this up like this, and then you can just use your power rule. You'll get the same answer if you would have used quotient. Y prime equals negative 1 x to the negative 2, which is just negative 1 over x squared. Do you guys want to see what would have happened if I would have done quotient? Don't write this down, just listen. Bottom, x times root of the top, 0, minus top, 1 times root of the bottom, 1, over bottom squared. And look, that zeroes out, negative 1 over x squared. You would have gotten the same answer if you would have done quotient, but why do you want to do all that work when you can just use power rule and get the answer immediately? Cool or not cool? Bless you squared, bless you cubed. All right, here we go. Square root of x. You doing all right, Ian? All right, so square root of x. This is x to the half. So when I take a derivative, y prime equals, bring the half to the front, x to the negative half. Sorry that I put the 1 kind of bendy there. If you want to turn that into an exponent, a positive exponent, 1 over 2x to the half. And if you want to put it back in radical form, 1 over 2 square root of x. Are we okay? Okay. Here we go. This is something that you would maybe do, maybe not your freshman year at the university because you don't have enough math background unless you're a STEM major. Maybe this is something that you do if you're a graduate student. Look what it says. If a gas in a cylinder is maintained at a constant temperature, the pressure P is related to the volume V by the formula of the form P equals nRT over V minus NV minus AN squared over V squared, in which A, B, N, and R are constants. Find dP dV. So this means how fast is the pressure changing with respect to volume. The derivative of pressure with respect to volume. Are we okay? Okay. We haven't done anything, guys. We haven't done anything. So here we go. Yeah. P equals, I'm just rewriting it, nRT over V minus NB minus AN squared over V squared. All right, let's see what's a constant. A, B, and R are constants, and T is a constant because it's a constant temperature. Are we okay? All right, here we go. dP dv is equal to bottom, and what rule am I using? Quotient. Bottom v minus nb times derivative of the top, and r and t are all constants, and r and t. So the derivative of the top is minus top and rt, put that in parentheses, times derivative of the bottom. So we're just going to write the derivative of v is just 1, because it's with respect to v. It's like an x. The derivative of x is just 1. And then nb is a constant, so there it is. All over, I'm just doing this first term right now, all over bottom squared. Am I okay so far? Okay. Minus, and I'm gonna go ahead and color code it. I'm gonna put that in that circle that's sky blue. Bottom times derivative of the top, 0, minus top, an squared, times derivative of the bottom. What's the derivative of v squared? 2v. Can I fit it in here? Let me write it smaller again. Sorry, guys. So bottom v squared times derivative of the top, 0, minus top, an squared times derivative of the bottom, 2v, all over bottom squared. All right, I'm going to make it pretty now. You guys ready? All this circled is that. So here it is, me making it pretty. So I have in the top negative n, okay, nRT, it's because I was going to put this term first because it's positive, v minus nb squared, and then minus a negative turns it into a positive. Child, what are you talking about? That zero's out right there. And I have a negative and a negative. So negative times a negative is a, so 2v an squared over v to the fourth. Yeah, 2v squared. One of the v's cancels out of this one. One of those or one of those, so it's 3. So here it is. I'm going to rewrite it. I'm going to put the positive term first, guys. 2an squared over v cubed minus nRT over v minus nb close it squared. Maybe we don't have enough experience yet to, this is kind of already started with related rates, but this is an example I would assume of someone who's doing graduate school in chemistry would probably do. They need to differentiate pressure with respect to volume. So hopefully now you're seeing how strong and powerful calculus is. If you're a STEM major, you're going to be doing calculus for the rest of your life. Cool or not cool? Don't cry, miss. All right. Here we go. We're just practicing now. We're just practicing taking derivatives. How about this? What's the derivative of cosine? Negative sign. Good job. All right, Delgado, your turn next. What's the derivative of tan? Good job. All right, here we go. Here we go. dy dx equals, I'm doing the derivative of question 6, guys. All right, focus, guys, focus, miss. What's the derivative of x? 1. What's the derivative of cosine? Negative sign, but I already have a negative, so it's going to turn into a... There it is. That's it. Cool or not cool? Look at question number 7. Before you do question 7, I would transform this. Don't do quotient rule for 1 over x. I would write that x. I would bring it up. X to the negative 1 plus 5 sine x. And then I would take a derivative. So here we go. Y prime equals, what's the derivative of x to the negative 1? What's the derivative of 5 sine x? 5 cosine x. Perfect. So then I would write it like this. Negative 1 over x squared plus 5 cosine x. And now you can just put equals because that signifies that you're doing the derivative of the top. Are we still okay? All right, here we go. Number 8. Y prime equals, the derivative of 4 is 0. Leave it alone. Group the negative with the x squared, or you can just do product rule with the inside. Dang it, I gave an answer. What rule do I got to use to take the derivative of this? product rule. The first is the negative x squared. The second is sine x. First, negative x squared times derivative of the second. What's the derivative of sine x? Cosine x plus the second sine x times derivative of the first, which is negative 2x. I would just make it pretty. Chavez, how do you make it pretty? Like this. Negative x squared cosine x minus 2x sine x. Leave it alone. Question number 9. I'm going to go slow. Okay, I see some of you guys still writing, so I'll wait. Question number 9. Don't take a derivative yet. Remember, if you see a constant somewhere, you can probably make it simpler. 4 divided by cosine is the same thing as 4 secant x. Cosine and secants are reciprocals of each other, guys. So baby pre-calc, nothing crazy. All right. Do I know the derivative of secant x? What is it, Marchan? Yes.
No, I have no idea. Like, I was not paying attention.
Oh, what's the derivative of secant x? You know it.
The derivative of secant x is going to be secant x tan x.
Say it loud and proud.
Secant x tan x.
So the YouTube can hear you.
Secant x tan x.
Yes. 4 secant x tan x. There it is. Yay or nay? All right. Question 10. Y prime equals, this one we're going to have to do what rule? Quotient. Bottom, 1 plus cotangent x times derivative of the top. What is the derivative of cotangent? Negative. I think I heard someone say it, but everyone's all over the place. Here's how you remember it, guys. If the derivative of tangent is secant squared, and tangent and cotangent are related because they're reciprocals of each other, then the derivative of cotangent must be negative cosecant squared. Cool or not cool? All right. So if the derivative of tangent is secant squared, the derivative of cotangent is negative cosecant squared. Anything that starts with the letter C, the derivative is negative. Cool or not cool? So bottom times derivative of the top, plus or minus? Minus top, cotangent x, times derivative of the bottom, which again is going to be all over bottom squared. Yep. There might be a simplification. There might. I'm not concerned about simplifying right now. We're going to leave it alone. Yay or nay? All right, here we go. We got to start getting better without a calculator. So here we go. It says, find an equation for the lines that are tangent and normal to the graph of y equals sin x plus 3 at x equals pi. I need 2 things for a tangent line. What do I need? Let's get our point first. Plug in a pi. When I plug in a pi, sine of pi is? Oh, man. 0. And 0 plus 3? Does everyone know how we got the point? All right, now to get my slope, how do I get it? Take a what? Take a derivative. Y prime equals, what's the derivative of sine x? Cosine x, and then the 3 is a constant, so it goes away. And then I plug in y prime, I plug in a pi. What is cosine of pi? Positive or negative?
Negative 1. I wrote over there.
So there it is. Y minus 3 equals negative 1 parenthesis x minus pi. Close. This is your tangent. I want to get my normal line. The only difference between a tangent and a normal is what? What's the opposite? Yeah, what's the opposite reciprocal? The slope. Y minus 3 equals, opposite reciprocal of negative 1 is just 1. I guess you don't technically need to put it there. X minus pi. This is your normal. If I go to Desmos really quick, let's look at it so we can see how awesome it is.
Why do my x is not so small? That's an
All right, Here's how it looks on Desmos. It's going to be beautiful. I would have done it on a TI-84, but I feel like it looks more beautiful on Desmos here.
Probably because Desmos is a lot faster. And it shows like this.
Well, it's not faster right now because I'm using my hotspot probably. Come on, buddy. All right, here we go. And I'm going to have to edit this part of the video because it's going too slow. All right, here we go, guys. The equation was y equals sine x plus 3. Sine x, close it, plus 3. All right, my tangent line. Y minus 3 equals -1, parenthesis, x minus pi. And look at that. It looks like a tangent. It looks perfect. Like, well, yeah, let's put the point there. So what was my point again? Pi comma 3. Okay, there it is. See? Tangent line. I don't want to label it. All right, check out my normal. Check out my normal, guys. Y minus 3, and then equals, it's going to be 1, so I don't have to put anything now. X minus pi. And there it is. And that definitely looks perpendicular. Cool or not cool? Yeah, that's how a tangent line's supposed to look, guys. I'm gonna remember that. What am I gonna remember from the class of 2024? Tangent lines. Okay. Matter of fact, I'm gonna put in the banner that I create for you guys, I'm gonna sketch a little tangent line. All right, question 12. Which of the following defines the instantaneous rate of change of the function with respect to t? And they give you a whole bunch of answer choices, A, B, C, D. What does instantaneous rate of change mean? I got to take a what? A derivative. Perfect. So what rule do I got to use for this? Quotient. So bottom, and I'm taking the derivative with respect to t, guys. Sine t minus cosine t times the derivative of the top. What's the derivative of sine t? Cosine t. Make sure you put a t in there, guys. Plus or minus? Minus top. Derivative of the bottom. What's the derivative of the bottom? Cosine t plus sine t. Yeah, you can say minus a negative sine t, which turns to a positive anyways. All this is over. Notice that answer initially is not there, at least not like that. You're going to have to do some algebra, just distribute. So here's what I have now. I'm going to have, let me see, I'm going to put equal sign sine t cosine t minus cosine squared t, and then minus sine t cosine t. I'm doing this. And then don't forget that negative there, minus sine squared t. All this is still over sine t minus cosine t, close it squared. Catch up. What is going to zero out in the numerator? Now that I've zeroed that out, I want you to focus that the negative cosine squared t minus sine squared t, I can factor out a -1, and that will turn into cosine squared plus sine squared. Do you guys see that? Negative factored out. I know I'm going into question 14, but that's okay. Cosine squared t plus sine squared t all over sine t minus cosine t squared. Valentine's Day is coming up. Well, no, actually, we're still pretty far away. But, you know, for Valentine's Day, please use that quote. And if they don't get it, your significant other, just upgrade, you know, just dump them. No, for real. I'm kind of being serious. Or educate them. But if they don't want to hear it, then just dump them. Cosine squared plus sine squared is the same thing as 1. So I have a -1 on the top over sine t minus cosine t squared. So what's the answer? B. Well, it does say find the instantaneous rate of change, so you don't have to say y prime. All those are rates of change. Instantaneous rates of change. All right, question 14. I must have deleted it then. All right, question 14. You look at it, you can do it by hand. It's going to take up the whole page. Or you can recognize, come on, Espinosa, focus, miss. You can recognize what? That this is just what? Yeah, which is what? Derivative. It's a derivative of what function? Cosine. So if my function is cosine x, what's the derivative of cosine x? No, we would have done it the long way. Negative sine x, and then if you have to use composite argument properties. So look for that answer. All right, look at 15. Question 15 would take up the whole page if you don't recognize it. If you don't recognize question 15, it will take up the whole page because you come out, well, not the whole page, maybe a quarter of it, because you got to multiply by the conjugate. Recognize that that's the what? Guerrero, you know the answer to this. The derivative of what? Yes, the derivative of square root of x. Way to go, miss. So the derivative of square root of x. So you turn that into an exponent, x to the 1/2. F prime of x, take a derivative, 1/2, x to the negative 1/2, and then that's it, you're done. Chop, but I don't see my answer in there. It is in there, you just got to fix it. 1/2, x to the 1/2, and remember x to the 1/2 means square root. 1/2 square root of x. Are we okay? All right, question 16. You don't have to do it the quotient rule, guys. You can. I always think it's easier to use power rule. It says find an equation for the line challenge the curve x cubed plus 1/2x at x equals 1. So how do I know when to do quotient and when to do power? If you're dividing by one term, you can always make this simpler. So this is the same as saying x cubed over 2x plus 1/2x, which is the same thing, cancel one of those x's, as 1/2 x squared plus 1/2, bless you, x to the negative 1. I brought that x up, and I canceled one of the x's. For a tangent line, I need two things. What and what? Point and slope. Let's get the point. If I plug in a 1 into the original, 1 plus 1 is 2, and 2 times 1 is 2, and 2 divided by 2 is 1. So I see that. Now I'm going to find a slope. So do I still have Desmos open, or did I close it? Or yeah, I still have it open. Good. Y prime equals, here's my derivative. What's half of 2? 1, and I subtract 1 degree from the x. And then half times negative 1 is a negative half. X to the negative 2. So let me fix this. X minus 1/2x squared. Y prime of 1 equals, I'm just plugging in a 1. 1 minus 1/2 times 1 squared. So 1 minus 1/2 is just 1/2. Are we okay? What's my tangent? Y minus 1 equals half x minus 1. If I did everything correctly, let's see how this looks. I'm going to take off my Desmos here. I'm going to clear everything. Give me my original equation. I already forgot it. Y equals x cubed plus 1. Oh, dang it. I didn't put parentheses. Sorry, guys. I should have done it. I should have listened to you guys. Plus 1 all over 2x. Okay, there's my funky graph. Let me put my point first, not ruin the surprise. 1, 1. And now, I don't care about labeling it. You can. See, well, you know what? There it is. What's my tangent? Y minus 1. And look at that. That definitely looks like a tangent, guys. Delgado, that looks like a tangent. Definitely. Cool or not cool? Okay, let's keep going. Question 17, last one. What rule do I got to use for this one? This one, there's no going around it. You have to use quotient. Here we go. Y prime equals, you guys tell me.
2x plus 1 times 4 minus 4x minus 3 minus 2 over 2x plus 1 squared.
You should say 2x plus 1 quantity squared, but that's fine. I get it. Yeah, because it's 2x plus 1, the whole thing. If you say 2x plus 1 squared, it sounds like you're saying 1 is squared. All right, here we go. Now you're done with calculus, guys. The rest is just algebra. So 8x plus 4 minus 4 times 2x is 4x times 2, sorry, is 8x. Negative times a negative is a, so plus 6 over, you don't have to make the denominator, you don't have to expand the denominator. The 8x's cancel out. What is 6 plus 4? And there it is. .14. Look at the time we finished. All right. All right, guys. Some of you haven't attempted your quiz from yesterday. Some of you did. I would say half the class did. Attempt the UH quiz derivatives 1. I think it's quiz 7, I think. Attempt that one. There's no new homework, and that's all I asked. You attempt it, and we're done, guys.